Hi everyone, this is Liam Eagle. I'm the Editor-in-Chief here at the WER, and I'd like to welcome everyone to another of our WER webinars. I'll be moderating today the session called DNS for Hosting Companies, Ensuring Zero Downtime, which is sponsored by Nominal, and will feature Dr. Paul Mockapetris, the Chairman and Chief Scientist at Nominal, and Paul Evanson, VP of Network Operations at Nominal. A couple things I wanted to, a bit of a housekeeping before we get right into the presentation. There's going to be a Q&A period at the end of the presentation, and feel free to submit your questions throughout, but we're probably not going to answer the questions until the very end of the presentation. We do have a record of all your questions, so if it doesn't get answered during the course of the presentation, somebody can probably follow up with you after the fact. And there will be some contact information for Nominal on the screen near the end, so if you have a question that you want to ask sort of outside of the context of the presentation, you can certainly follow up with them directly afterwards. And finally, if you're looking for a copy of the slides, you can contact Nominal at the end, and they'll certainly be able to get you those to you. And of course, an archived copy of the webinar will be made available on the WER after the fact at the wer.com/webinars, along with all our other webinars, and most likely on the Nominal website. Although I don't believe that they've got a specific location yet, but I'm sure you'll be able to find it. So I'm going to pass the controls over to Nominal, but before we begin their part of the presentation, I'm just going to do a little bit of an introduction to Nominal itself. Nominal was founded in 1999, and in 2002 released CNS and DCS, the first ever commercial-grade DNS and DHCP product. As a result of their technical expertise and commitment to quality, these products became recognized as the platinum standard for world-class network owners. Today, Nominal is a recognized industry leader that provides DNS software and related services to major internet service providers and enterprise customers around the world. Nominal DNS solutions are used by over 500 million internet users every day. Nominal has become the de facto DNS industry leader, offering 100% uptime, along with top performance and scalability. Collectively, Nominal customers generate trillions of DNS transactions per day, and the hosted Nominal global network has the capacity to handle up to 4 million queries per second. In addition, in an era full of malicious activity, Nominal provides the most comprehensive and operationally efficient DNS security solution available by, for example, making DNSSEC easy to implement. But Nominal is more than just DNS. The company provides in-network software systems, off-network hosted services, and even consumer applications which help improve the internet experience for end users. Simply put, Nominal just makes DNS more intelligent. By the way, just a couple of weeks ago, Nominal launched its brand new website, which is at www.nominal.com. In this webinar, we are delighted to welcome Dr. Paul Mockapetris himself, the inventor of DNS, who is calling in all the way from Paris to talk about the current state of DNS and current trends. The second part of the webinar will feature Paul Evanson, Nominal's VP of Network Operations, who will discuss the problems facing hosting companies and how to mitigate these risks and ensure zero downtime. The webinar will also explain some steps you must consider when selecting the best DNS for your network. So I'd like to welcome Paul Mockapetris to the webinar. Maybe take a moment to introduce yourself before you start the presentation, and then take it away, Paul.
Well, thanks very much. I think we'll move on to the first slide. The easy way to think about DNS is to just go back to the basics. What is the DNS? Well, it's sort of the ingredient in every activity that takes place over the internet. Each time an email crosses the internet, on the average, there's about 12 DNS lookups that decide how to route that message, as well as to help decide whether or not it's spam and should be thrown away. When you display a web page, it's hard to know how many lookups there are. Last time I looked at the New York Times, there was 8 DNS lookups for the single view of their main page. Whereas when you take a look at Facebook pages that are made up of lots of tiny little inserts and so forth, you can have 200 per page. So what we've done over the years is to figure out how to base more and more network activities on top of the DNS, using it to look up the locations of content hosts and the like. I think that in the future there's other things that are going to happen here. More and more it's going to be used, for example, to route phone calls. A lot of people wonder about whether or not the performance is there, but if you think about it, most people get many more emails every day than they have phone calls to set up, and the routing is pretty similar. So those are the kinds of things that are with us. Every activity requires some number of DNS lookups, and the number is growing as content becomes more complex and interactive on the web. What are the keys to performance? There's basically the pitching and the catching. There's the fast publish of DNS data. In other words, if you're hosting a web page, you have to make it available, and you have to make that data available to any internet user that wants it. On the other end, there's the fast lookup of DNS data, caching servers. These are typically things that host, perhaps 50,000 broadband users on a cable system or DSL or whatever, and take care of looking up DNS data for them, that data being eventually sourced by the authoritative servers. Having both of these work well and fast is really the key. But beyond that, being fast isn't enough these days. You also have to be resistant to attacks, misconfigurations, and Murphy's Law in general. Let's move on. Next slide, please. So I think what we've seen over the years is an evolution. When the DNS was first introduced, it was designed to be very simple. That was more than 25 years ago now. It was designed to be very simple and very lightweight. As time went by, people decided that they needed standard implementations, reference implementations. Nominal did one of these originally, by 9. But these systems weren't adequate for a lot of the large-scale users that we support. They required you to restart the system, reload all the data every time you want to restart the server, or change configuration information or whatever. They also weren't resistant to attacks, and we'll talk about some of the details of that. So what we've done is, as we moved along in the evolution, we've now come to a point where creating services out of the DNS that do things like suppress names that are undesirable for one reason or another, or recognize attacks and deal with them. Part of that resistance is DNSSEC and an end-to-end service architecture that lets you provide different kinds of services to different classes of users. What are some of the characteristics that in this evolutionary progression that make for survival? Well, they're on the next slide. On the authoritative side, there's no substitute for speed. The more users you have, they want to see the content, they want to see it quickly. The faster you are, the happier the users are going to be. Being fast also means no reloads. In other words, if you want to change the data in the database, or if you want to change the configuration of the database, you should never have to restart the server to do that. Similarly, if you do restart the server just because you've decided to modify the hardware or whatever, you don't want to have to wait half an hour or an hour to read in large configuration files. You want to be able to instantly restart. So availability as well as speed is very important. One of the things we've found, service providers in particular, you need a real-time dashboard. You need to be able to understand what's going on with your system. You need to be able to know when you're having an attack. And attacks can come both to the authoritative and the caching side. There's lots of cases in the past where high-profile websites, like gambling websites or just political websites, came under attack. And today, authoritative servers for those kinds of sites, as well as some TLDs, are coming under attack. Being able to recognize the attack is the first step in being able to deal with it. But similarly, you need to do capacity planning to make sure that you never run out. Scalability is another aspect. One of the questions that came up was, could we create a domain name for every person in Germany, for every phone number in Germany, a separate zone for those of you that are DNS aficionados? We ended up having to go back to the drawing board and redo the product just to make sure that if you ran a server with 1 million zones, that it would work well. There's lots of implementations out there that are still relying upon techniques that don't scale, so that all of a sudden when you're successful in your business and you create more and more data, all of a sudden it can fall off a cliff. In particular, you have to worry about implementations where as they get more and more heavily loaded, all of a sudden they start to slow down. Because if a heavy load causes you to slow down, that means that you're going to fall off the cliff on the other side and die. Attacks are out there, so you need to be attack resistant. On the authoritative side, recognizing it is the first step, but the other question is, what are you going to do about it? Lastly, on the authoritative side, there's policies. The simple side of policies are views and things that let you see a different view of a DNS domain based upon whether you're inside a company or outside. But increasingly, we're seeing evolutions of these to make different kinds of views available for different users. On the caching side, speed is there, recognizing attacks. The attacks typically take a different form here. Very often, these are attacks that are coming from the user trying to implement cache poison or whatever. One of the things that caching servers should do is to just slow the attackers down. There's a bunch of defenses that are based upon the fact that you should just let the attacker pummel the server. This is a problem because statistical attacks that just can launch millions of queries in the course of a very short time over, say, a 10 gigabit Ethernet. A corporate fast network subjected to a statistical attack that only has one chance in 4 billion, which is the case with the 32-bit ID field, that still means that over 10 gigabit Ethernet, you're only talking about hours before it's likely to succeed. You have to worry about those kinds of things, and you need to slow the attackers down. One of the ways, and this is just analogous to if you try and type your password and you get it wrong, most systems will require you to wait a bit before you can submit the next test. We do the same sorts of things in DNS caching servers. And lastly, you need to learn. You need to be able to observe what's going on and also learn who the good guys are and who the bad guys are and deal with them. These are just the general survival characteristics on both the authoritative and the caching sides. Next. All of these are observed by users. DNS doesn't hide anymore. There's articles from the Register to the New York Times. And we see articles recently talking about how some of these services in the net are the way to go. We've certainly heard about Google and OpenDNS. One of the questions we have about that is that while it's always possible to do worse than some of these services in the cloud, what should you expect? What's the right metric? In general, a service provider who has provisioned their network adequately is several hops closer to the user than any of these services and has a certain advantage. When does that matter? But the key thing is that users want to be able to have the network just work and fast and accurate answers and immunity from being led into malware sites are the things that are expected by the users for DNS services these days. Next. So I guess some of the trends are DDoS and malicious traffic growing rapidly. One of the rumors is that some of the registrars of the DNS system, particular TLDs, have been subjected to the same sort of blackmail attacks that have been common for gambling sites and the like. You need to have an increasing strength, either by building it yourself or by acquiring it, for these denial of service attacks. They're coming and they're getting larger. The traffic just the normal user traffic is growing and growing fast. We'll talk about some of the details. And lastly, there are new standards for security, such as DNSSEC, that lately has been getting a lot of press. Why is this important? Next slide, please. The reason that DNSSEC is so important is that there's a security gap. The threat level in DNS, there's always been people attacking DNS. A lot of people talk about the Dan Kaminsky bug, which is the cache poisoning bug that got a lot of press starting in 2008. In reality, the DNS started out with no security at all. That was part of the design. And Dan exploited that to the hilt. But the threat level has really been there before Dan and will probably increase after Dan. The attackers have just steadily gotten more clever about how they attack the DNS infrastructure, particularly without a planned defensive mechanism. So what we've done in 2008 is we saw Dan's attack all of a sudden made it clear that defenses that just rely on source port randomization, UDP source port randomization, or no source port randomization at all, were just defenseless pretty much against an attack. The question would be, how long would it take? You know, the Nominal implementation, we were much more paranoid from the start, and so we largely have stayed above that, although we're concerned to make sure that the future eliminates most of these attacks. That's going to happen when we have the widespread use of DNSSEC, sort of the third era here. That's going to lift everybody's security quite a bit. The question is, when is that going to happen? This slide suggests 2011, and certainly if you've been listening to a bunch of the publicity from ICANN and some of the other top-level domains about the deployment of DNSSEC, you can see that there's some progress that's been made, but when is DNSSEC going to be deployed in half of the net? It's hard to know. I would guess that it's a date that's something more like 2013 to 2015, just because it depends upon software being changed in all the systems in the Internet to both associate digital signatures with all of the DNS data. Again, the publisher authoritative side, you have to create a digital signature and put it on the data. And also on the caching side, you have to check the signatures. This makes all of the DNS data circulating several times larger because the digital signatures are larger than the data they protect. It's a question, it's a technology that's going to help us a lot, but being able to deploy it today is a real issue. Because one of the things that you have to do is not only sign the data, but you have to periodically re-sign the data with a brand new key. And we at Nominal think we need to do that all in an automated fashion because the computational load is large and you have to plan ahead if your server is going to be sure to be able to complete a re-signing of all your authoritative data before that new version of the data is necessary. There's other complications and we'll talk about them a little bit later. But I think right now we've got to realize that the majority of the Internet is going to stay in this DNS 2.0 era where they're vulnerable to the Kaminsky style attacks. And that servers that don't use some of the advanced security mechanisms, such as we use at Nominal, are really below the ability to deal with the threat level that's out there and will be vulnerable. Next. What do you see in your network? We spend a lot of time analyzing DNS data. Unusual query patterns are one of the ways to detect malicious activity. For example, the Kaminsky attack is characterized by a bunch of queries for domains that don't exist. Yes, that's names that don't exist are part of the ways to poison names that do exist. It's technical and complicated. Similarly, if you see a bunch of MX queries coming out of a bunch of users, what are they doing? Well, they're either sending a lot of mail or perhaps sending a lot of spam. One of the ways to detect spammers is to take a look at their DNS activity. Conpicker, the famous bot out there, also uses the DNS to organize its own activities, and the queries that it makes can be examined in order to detect machines that are infected. There's many more activities that can be characterized the same way. But the point is that DNS is a way to measure the activity of the network and to also measure which activities are going on. Some of these are just going to be misconfigured clients, but oftentimes they're going to be malicious activities by bots or otherwise compromised activities. Measuring user activity is another important part of this, and you need that real-time visibility in order to make sure that users are getting the performance that they expect, and also to understand what you need in terms of adequate capacity to make sure that your network is performing the way that your users expect. Next slide, please. These are some numbers from VeriSign about the growth. Right now, I estimate that there's several billion pieces of DNS information out there, and that the query rate on that is continuing to grow. It hasn't stopped, and because we've been so successful in reducing the cost of an individual query, it's become a building block for more and more complicated services. In other words, because DNS queries have become cheaper and cheaper, people have found more and more uses for them, and that trend shows no evidence of slowing down. In addition, many companies now are hosting their names in multiple domains, perhaps in multiple character sets, as we've now had Russian top-level domains and Arabic top-level domains and so forth, to be followed by other character sets in the future. The growth just continues. Next, please. Next slide, please. DNSSEC is here for the top-level domains and is here for many activities that are very sensitive and need to be protected. An example of that is some of the data that's distributed about how networks are allocated in .ARPA. There's banks that are using DNS security in Brazil. Sooner or later, all of this data is going to need to be protected. The problem is, it's as if every house in the world didn't have locks and all of a sudden we're going to install them. Well, we also have to make sure that people get that into the user's model and into their browsers and into their mail servers and so forth. Because one of the questions is going to be, what happens when data is slightly misconfigured and the security system says that that's a problem? We're going to have to deal with that. And we're going to have to deal with a number of the other activities that are necessary in order to make DNS security happen and happen soon. Because although some of the early work has been done, what we're really going to need is 2 or 3 years of active experience and user education. Even if the software is perfect today, educating the users about how to use these facilities is an important aspect. Next. One of the important things to realize is that many of the attacks that you hear about are based upon the fact that a lot of the DNS software that's out there is legacy and hasn't been kept up to date with the threats that are out there. A classic example of that, I have one in my own home. There's a DSL box that has an old version of DNS code. Hasn't been updated in many years and probably won't. But people run older DNS or DNS code that's vulnerable. these are but a small set of examples of the problems that you can see, whether it's vulnerability to a DDoS attack. Because there's a bunch of DNS software that's out there that works really fine until it sees a DDoS attack and then it falls over. So these kind of non-stop attacks are exhibiting the weakness of a lot of the legacy DNS software that's out there, and will continue to do so in the future. Next. So what's in this for hosting companies? Well, I mean, your job is to make sure that the content, the content gets out there. And that's what drives the users. Secure content for transactions is going to be one of the big things that's coming about. The IETF is currently looking at replacing certificate infrastructure with DNS data. Since DNSSEC is there to secure it, there's lots of possibilities about making the internet much more secure. Large enterprises, small, they all need these kinds of very robust services. The right answer may vary a little bit depending upon your scale. A smaller enterprise might choose to outsource this. A large carrier probably wants to have its own infrastructure. In between, you may have hybrid systems where surge capacity is in an outsourced system. So these are the kind of issues that we've seen in the DNS, and I think now I'm going to turn the discussion over to a presentation about specific aspects for hosting companies.
Paul Mockapetris, thank you very much. It was a great DNS overview. And now what I'd like to talk about is a little bit more detail about how DNS applies to hosting companies. In today's industry, the demand for hosting is going up. It's a very good market out there right now, but there is a lot of competition out there. And some of the challenges that are faced by the hosting companies are things like the performance of your hosting environment, including latency and making sure that we have low latency, network coverage so that you can maintain that performance globally, reliability, downtime is absolutely cannot have, and then provisioning. Again, the margins in today's business are getting a little bit thin based on price competition, so the automation of your environment is very, very key. Paul talked a little bit about the DNSSEC and how that's becoming a important component of your DNS, but as well as the network security, intrusion protection, DOS protection, that sort of thing. And then again, we live a little bit in the wild, wild west with the amount of DOS attacks that are occurring out there. Most recently, we heard publicly about a major DOS attack that occurred against the DNS environment that was up to 40 gigabytes. So they're getting bigger and bigger as we go through time. The considerations is because as Paul pointed out, DNS is a central point of your hosting environment. And some of the key considerations when you think about DNS and how you build that into your environment are a few things. One is architectural flexibility, to be able to adapt DNS most appropriately to your existing environment. That could include a in-software solution or it could be a hosted solution. Network robustness, critical as the network becomes more and more bigger and bigger and more activity out there. The network robustness is going to be key, as well as being able to provide the reliability that plays into the hosting provider's SLAs. Seamless integration, the ability, as I mentioned before, to tie your DNS as well as all the other components of your network into your automated provisioning and billing systems. Being able to support the progressive trends such as DNSSEC, and then again to mitigate the DOS attacks and the increasing DOS attacks that we're seeing out there in the environment. As you look at your DNS strategy, what the results will be increased flexibility, your ability to adapt to market changes, to provide new services, getting closer and closer to real-time provisioning, not having to wait for your new customers to come online, greater control over your environment, including the provisioning of DNS and how it's propagated, the TTLs, all the components that go with DNS. Lower cost of your DNS environment. It's a critical part of your environment, but it has to play into your margin goals. Improve security to make sure that you don't have any mishaps or intrusions or disruptions to your network. Zero downtime. Again, the reliability is key, and it's very important in today's competitive environment, as well as your SLA requirements. And then simplicity of the operation, so it doesn't require a huge amount of overhead to manage and maintain. Let me talk a little bit about the Nominal intelligent DNS and how we've addressed some of these problems or challenges today in your thought process for the selection of DNS. As I mentioned before, there's a couple ways to approach it. One is to have software that resides within your own network, but that creates the requirement for the management of that software within your environment. You can outsource it to a hosted DNS provider, so that you don't have any of that within your network, but you're relying upon your hosted DNS provider. Or it can be a combination of both, so that you can build an infrastructure of your own DNS software within your own environment, but offload other peaks to a service provider, or to be able to provide the backup to your existing DNS environment that may be in-house. So all three are options out there, and InNet, which is your own software, and OffNet, which is a service provider solution, or a combination of both. The InNet OffNet at Nominal works really well. It works together seamlessly because we base our service provider solution on our internal software. So we know both of them, they work together seamlessly, and they're made to work together seamlessly. A little bit about the in-network, what we call our ANS software for the Nominal solution. It's a proprietary database. It scales up to 1 billion resource records per server, so it's very, very scalable. Very high performance, and that comes into play in a number of reasons, not only to be able to handle existing capacity, but also to be able to absorb the peaks and valleys, including malicious activity like DOS attacks. It includes on-the-fly DNS zone updates without requiring server restarts, as Paul mentioned earlier, and then fast reload times. Our software is fully compliant with DNSSEC. We've always been a DNSSEC leader, and we continue to be. Seamless integration into your existing environments. That's both on the, especially on the, in-network solution, to be able to tie in via the common programming languages such as Perl, SOAP, Python, etc. And then we provide network visibility across the entire network. If you have multiple servers, we can give you visibility into the holistic environment of all your DNS services, and then multi-mastering support as well. Our off-network service for authoritative DNS is a hosted DNS. It's in the Nominal global network. It has programmatic APIs, so again, you can tie your existing provisioning systems into our network. It's secure and efficiently to provide the right answers to domain requests. We do support DNSSEC across the entire network, and it ensures availability, security, and performance across the globe. Key features includes a portal so that you can make changes, query the network, or make modifications through the portal. But it also includes an API, so you can tie it back into your in-house systems. It's sub-second propagation of zone updates across the network. It includes global load balancing to route DNS requests from the nearest and best DNS server. And again, DNSSEC is stable, proven, and simple to deploy. The challenges of DNSSEC, as I've mentioned a couple times, is the signing and re-signing of zones. It's very CPU intensive. The database size can become big, 6 times more than normal. Administrative challenges, the managing and signing of zones, and updating zones when data changes are all key challenges you need to think about when you're deploying DNSSEC. Nominal provides DNSSEC in what we call our DNSSEC pack. It bundles that. It includes a bundle that manages DNSSEC lifecycle automation. All activities are done via a single command utility, and it's completely integrated and completely automated. A little bit more about the Nominal Global Network is a full service network that we've deployed around the globe. It's highly redundant. We have multiple, ISP connections, Tier 1 ISP connections, so that you can reduce your hop count in your route paths to the closest DNS server. It's fully redundant. It's in carrier class data centers around the world. It has site level redundancy, so we both have local redundancy as well as global load balancing across all the data centers. It's based upon Anycast architecture, so that you are going to go to the closest and best data center and DNS server, but it also provides you with the opportunity that if you have to reroute to a different data center, that we have multiple data centers that are all able to service that request. And again, all of them are DNSSEC compliant. Talk a little bit more about DOS attacks. Like I mentioned earlier, there was recently a major attack against a DNS provider. So that we're seeing DOS attacks are becoming bigger and bigger and more sophisticated in their approach. As I said, it was about a 40 gig attack on one of the providers, and it's very expensive. These are all stats that we've pulled from industry standards that, they're not, multi-megabit attacks anymore. They're multi-gigabyte attacks, and your provider for DNS has to be able to, mitigate those attacks. The way that we approach it is we do it in a number of layers. Number one, just the performance of the software being able to handle 100,000 queries per second makes the software very resilient and able to handle peaks that come along with the DOS attack. But we also do it at the network layer too, where we have multiple layers of defense at the network layer. We work with our peering partners to make sure that we have their full support and their security options available to us, as well as providing a third-party provider so that under the large attacks, the sophisticated attacks that are doing, valid queries against the DNS environment, we can offload that and help mitigate it through a third-party service provider. So the Nominal approach includes 4 layers of defense, and we're very confident that we can, provide the absolute best mitigation resources in the case of an attack. So that brings me towards the end of the hosting section of the presentation. Just to close it out, Nominal Intelligent DNS will make your service offering smarter, faster, safer, and more reliable for all of your customers, and provide you that competitive advantage that we're all looking for in today's environment.
So Liam, with that, I think we'll give control back to you from Redwood City here. I think we had a little bit of a PC versus Mac conflict in the conference room, and so one of them got shut down. We'll give you control, and then at this point, we'll start taking questions.
You know what, Paul? Why don't you guys hang on to the control, because then we can keep the Nominal contact information on screen. We can certainly. Now, I guess we were going to have. Do you have Erica on the line? Was she? Erica was going to field some.
Erica has logged some of the questions here, and then we'll start by Erica stating the questions, and then either Paul Mockapetris will provide an answer, or someone here in the room, Paul Evanson, on our end.
Okay, great. And just to remind people that also, if they want to submit questions while we're doing the Q&A, we're happy to have them, and hopefully we'll have time to get through all of them before the end of the session. So, Erica,
the first question I have here is for Paul Mockapetris. They're asking, can you comment on the current state of multi-language support for DNS? Paul, are you there?
You may have lost Paul Mockapetris.
No, I'm here. The specs for doing the multi-character set approaches are finalized now, and some of the TLDs are out there. One of the little secrets is that web browsers have for many years been able to work with Unicode. And so I expect this all to happen fairly quickly. I think more of the challenge is going to be for the administrators who all of a sudden have to start supporting these. I don't know how many languages the typical administrator is willing to learn in order to be able to read his own configuration files. So I think that's the issue. There's a long-term societal question about, is this going to result in more communications or less? But it's here, and it's popular, and it's particularly being used for Arabic and Russian, but the Pacific Asian languages are out there. There's a prototype system that's been around for many years in Korea. So it's a fact of life, and one of the things that you have to deal with.
All right, thank you. The next one I'm going to direct towards Paul Evanson. If I am a Sky Authority customer, is my DNS data available globally?
Okay, and just to reiterate, Sky Authority is the network solution that Nominal provides for the authoritative DNS. And yes, Sky Authority is available around the globe. We have data centers in every region, major regions in the populous areas, and based upon our Anycast network, provides redundancy and multi-location support for all the DNS queries that you may have in all the regions globally.
All right, thank you. Paul Mockapetris, this one's for you. Have there been any service providers that have already deployed DNSSEC?
There's several service providers that are putting signed DNS data out there. The root is the best known. Sweden and parts of .ARPA have been there for a while as well. The real issue is that not only do you have to have signed data out there, all of the user programs have to be educated on how to check the signatures. People also will be deploying servers that check the signatures for DNS users that don't have DNSSEC. In other words, you may be depending upon your ISP's DNS server to check signatures for you rather than doing it yourself. The original dream was that the data would be signed by the owner of the domain and that those signatures would be checked by the end user. I think we're going to see a lot of deployment where it's actually checked one hop away from the user in the user's ISP. But those infrastructures are out there, mostly for sort of prototyping purposes right now, but it is being used for some high-value applications and probably will entering the web surfing world in 2011.
Hey, Paul, this is Amit Dillon. Let me augment that answer a little bit if I could. For those of you on the line, I'm Senior Director of Product Marketing here at Nominal. So one major service provider from an ISP perspective, Internet Service Provider that you're probably all familiar with, is Comcast. And they've actually deployed DNSSEC. In fact, they made a major announcement this past February. And so if you're a Comcast customer today, you have the ability to essentially have DNSSEC validation to the extent that you go to sites, as Paul mentioned, that are DNSSEC signed. And I should mention that Comcast has deployed that with Nominal software, and they've also announced that next year, early next year in Q1, they're going to sign all 5,000 of their Comcast-owned domains.
All right, and I have one more question that I'm going to direct back to Amit. Is your multi-mastering capability in ANS an active-active architecture?
Yeah, that's actually a very good question. The basic answer is yes. It absolutely is active-active, and what that basically means is that as DNS updates are happening, this is a capability that Paul Evanson talked about within our ANS, or authoritative name server. As updates are happening, there are multiple DNS servers that are able to take these updates for fault tolerance purposes and service availability purposes. And both of those are actively taking updates, and they're syncing each other. The basic idea behind multi-mastering is that, take, for example, a DDNS environment, dynamic DNS environment, where you've got a lot of updates that are happening. These updates can go to any of the servers within the multi-mastering cluster. As I mentioned, they're synced with each other. So in the event of a failure of one or more of the servers within the cluster, the other ones can completely take over. So as I think Paul mentioned, you'll have no single point of failure as a result of that. And equally, or perhaps more importantly, you have availability of data, meaning as these DNS updates are happening, if you lose one server, you don't lose the updates because they're being replicated to the others.
Okay, next question I'm going to direct towards Paul Evanson. Are both caching and authoritative DNS available?
That's a good question, and we've talked largely today about authoritative DNS, but I also want to point out that we do have a recursive DNS or a caching DNS service available both in-network and off-network, just like DNS, authoritative DNS. All the hosting environments are largely dependent upon authoritative DNS. However, there is a need for caching, and the hybrid can support both.
Here's a question for Paul Mockapetris. What future services do you foresee from DNSSEC?
Yeah, I mean, one of the questions that we've had for a long time is DNSSEC is seen as something that will just make web surfing more secure. Is that all there is to it? Because the costs of implementation are pretty large. And the answer is no. For a long time, we've had people that have been thinking about putting particular applications into the DNS, but haven't been able to do that because the data wasn't secure. Now that the data is going to be secure, it's possible to think about many new applications. One of the applications that the IETF is currently working on and referred to before is basically to do the equivalent of a certificate infrastructure, X509, data in a DNS hierarchy using DNSSEC to protect it. One of the criticisms that people had about using DNS to route phone calls was that the routing of those calls would be subject to security glitches. And again, DNSSEC is going to remove that. One of the, I think, futuristic kinds of attacks, DDoS attacks are pretty blunt instruments. But for example, if people are able to exploit BGP attacks in order to route data so that they can watch it in transit, then the current methods of DNS security before DNSSEC don't work at all. So it will forestall those kind of combined attacks that use both BGP and DNS. I'm personally thinking that being able to do some of the applications that depend upon security, that need the security, RFID tag lookups, a bunch of other things, may enable a whole new set of applications to be used in the DNS. For example, if you're using DNS to distribute blacklist information in order to protect yourself from malware or spam or whatever, the last thing you want to have happen is to have people be able to spoof that data, because then they can force you to not have access to the internet. So I think there's a number of new things that are going to come along in DNSSEC, not just making web surfing safer.
Okay, I think we touched upon all of those there. So again, to view the webinar again, it will be hosted on the WER website, and we'll have it on our website as well.
Okay, so Erica, shall we wrap this up?
Yeah.
Okay, well, I just wanted to, before we close, say thanks very much to Paul Mockapetris and Paul Evanson for a lot of great insight into a subject that I think is of a lot of interest to a lot of people. And of course, thanks to everyone for attending. Thanks for submitting your questions, and let everyone know that yes, this webinar will be archived on the wer.com/webinars. There's also a webinar link right on the front of our page, and you should be able to find it really quickly. And it also will be archived somewhere on the Nominal website. So, and again, you should go check out the Nominal website. I was on there earlier today, and it's looking very nice. So thanks everyone for attending, and have a great day. Take care.